Yeah, I'm sharing my screen. Today we'll discuss about the operators. Okay, so what are the operators present in the Verilog, and we'll discuss about the we'll discuss some examples also. Okay, first we'll see about the logical operators. What are the logical operators we have? Okay, so logical operators. Yeah, first we see the logical operators. Logical operators. So logical operators, you have logical and, okay, logical and the symbol is double ampersand. Okay, logical R. Okay, logical R, logical R. Okay, logical R, and next logical not. Okay, logical not. Okay, logical not. Okay, so first, so the value of these logical operators are, so the value, so whatever the value of these logical operators are either 0, 1 or x. Okay, 0, 1 or x. Okay, so either it may be 0, 1 or x. Okay, and so here first we will see the logical operator. Yeah, but somebody are joining. Yeah, okay. So the value of a logical operator are 0, 1, x. Okay. Suppose if we take one example. Okay. So we are discussing the logical operator. So logical operators are logical and, logical or, and logical not. And the value of logical operators lies between. Okay. So okay. Yeah. So one second. Yeah. So here if you see the logical not, so let us take one example. So if you take one example, let us take range 1 down to 0 A. Okay, range 1 down to 0 A, and next range 1 down to 0 B. Range 1 down to 0 B. Okay, and next I'm considering reg x. Okay, reg x, and x equal to what? X equal to a logical and of b. Let us take x equal to a logical and of b. Let us take a equal to 2 tick binary 0 1. One second, extra 2 minutes. Sir, చెప్పండి సార్. గుడ్ ఈవినింగ్ సార్.
సార్ ఇప్పుడు నేను పంపించాను కదా, ఇది మనం ఎన్ని రోజులు టీచ్ చేయగలగచ్చు? కొటేషన్ ఎంత ప్రైస్ చేయొచ్చు ఇది ఒక కాలేజీకి?
మీరు పంపించారు?
నీకు అది ప్రాజెక్ట్ పంపించాను. మనం ఏం వర్క్ చేయొచ్చు వీళ్ళ కాలేజీ వాళ్ళకి? అంటే మనకి ఎన్ని రోజులు ఎక్స్పెక్ట్ చేయొచ్చు అని చెప్తే ఐడియా వాళ్ళని నేను వాళ్ళకి వర్క్ చేయగలుగుతాను.
ఇది ఎంబెడెడ్ ప్రాజెక్ట్ కదా సార్, VLSI కదా? ఆర్టీఎల్
మీకు సపోర్ట్ ఇది వివారో టూల్ అన్నమాట.
ఓకే 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 ఎస్క్యూఎల్సి అంటే మనకు క్లాస్ అంటే ఒక క్లాస్ ఎక్స్ప్లెనేషన్ అయితే ఒక 1 డే పడుతుంది, ఇంప్లిమెంటేషన్ ఒక 2-3 డేస్ పడుతుంది.
ఓకే ఓకే. అంటే మన డైలీ వర్క్ షాప్ టైప్ కాకుండా వాళ్ళకి 1 మంత్ అలా ఏదన్నా ఫీ చేయగలగచ్చు అనేసి, 1 మంత్ కానీ 45 డేస్ కానీ అలా ఏదన్నా డైలీ 2 hours అని అప్రిషియేషన్.
ఇది ప్రోటోకాల్స్ కదా సార్, ఇది ఒకటే ప్రోటోకాల్ ఇచ్చారు.
ప్రోటోకాల్ అదే కాలేజ్ ప్రాజెక్ట్ అన్నమాట వాళ్ళకి.
ఓకే, ఇది ప్రోటోకాల్ ప్రాజెక్ట్.
ఓకే, ప్రోటోకాల్ ప్రాజెక్ట్. అండ్ ఎన్ని రోజులు చేయొచ్చు? వాట్ ఇస్ ద బెస్ట్ యావరేజ్ టైం?
ప్రోటోకాల్ అంటే మనము ఇది స్టడీ చేయాలి. వన్ వీక్ సరిపోతుంది సార్. ఇది ఓన్లీ వన్ ప్రోటోకాల్.
ఫుల్ డే అంటే మనకు డైలీ 6 అవర్స్ ఉన్నప్పుడు ఒక 1 వీక్ లో అయిపోతుంది.
1 వీక్ లో సరిపోతుంది.
సరే సార్, థ్యాంక్ యూ.
ఓకే ఓకే. Yeah, sorry for interruption. Okay. 1 second. Yes. Yeah. Okay. So that means if you take b equal to what? B equal to, so take binary 1 0 if you take. So this is nothing but so two values are there, means it will take as what? It will take as 1, and these two values are there. So non-zero values means it will take as 1 only. So that means logical operator, if it is 0 0 means it will take as 0. Either it may be non-zero value 0 1 1 0 1 1, or it may be 3 bits also 0 0 1. So non-zero value it will take as 1 only. Okay, single value it will take. So that means one logical AND of 1. So that means here you are getting what? X equal to 1. Okay, x equal to 1. Okay, this is nothing but logical. So that means here we are taking a equal to 0 1 means what? It is taken as 1. That means true condition. Okay, if we are taking a equal to 0 0 condition, this is nothing but 0. This is false condition. It will take only one value, that is either 0 or 1. Okay, either 0 or 1. Okay, suppose if you take example, a equal to 2 tick binary 1 1 is there, and b equal to 2 tick binary 0 0 is there. Okay, so here I'm doing what? X equal to a logical AND of b. Okay, a logical AND of b means what? Here 1 1 means 1. Logical AND of 0. So logical AND of 0 means it will take a 0 only. Okay, it will take 0. Okay, and so this is let us take example 1, and if you take example 2. Okay, if you take example 2, so let us take a equal to 2 tick binary 1x, 2 tick binary 1x, and b equal to what? B equal to 2 tick binary 0 0. Okay, so that means here 1x means it will consider unknown condition only. Okay, x it will take, and 0 0 means it will take 0 condition. Okay, so that means x equal to a logical AND of b. Okay, a logical AND of b means here that means so a is what? X. Okay, a is what? X. Logical AND of 0. Okay, logical AND of 0 means what? Suppose x values don't care, we already seen in the digital. So the don't care unknown values are either 0 or 1. Okay, so that means here if you see 0 logical AND of 0 means what? You are getting 0. 1 logical AND of 0. Okay, you are getting 0 only. Okay, so that means from here I can say that the value of x equal to what? 0 only. Okay, while both cases you are getting 0 only. Okay, both cases you are getting 0 only. Okay, so like this we need to analyze. Okay, and next logical R is there. So logical R means what? Logical R, so let us take a equal to 2 tick binary 1 1 is there, and b equal to 2 tick binary 0 1 is there. Okay, so it will take as what? It will take as 1 true condition, and it is also take as true condition. So a logical R of B. A logical R of B means what? So one logical R of 1 means what? Y equal to 1. Y equal to 1. Okay, like that. Suppose, yeah. So example. So you can consider. Let us take a range 1 down to 0. So this is 2 bit A comma B. Okay, and range 1 down to 0. 1 down to 0. Result. Okay, result. Okay, result equal to what? Result equal to a logical or of b. Logical or of b. So what is the result? So that means you take a equal to 2 tick binary 1 1, and b equal to 2 tick binary 0 0. 2 tick binary 0 0. So this is 1 and this is 0. Okay, so R operation means what? You are getting 1. So result equal to what? Result equal to 1 you are getting. Okay, result equal to 1 we are getting. Okay, this is logical OR operation. Okay, so in logical OR operation, it may be non-zero value, it will take true condition, and if it is zero condition, all are zeros are means, so it will take us false condition. Okay, it will take as false condition. Okay, so that is about the logical OR operation. And logical NOT is there. Logical NOT. Logical NOT. So what is logical NOT? Logical NOT means here suppose A equal to 3 tick binary 0 1 0. Okay, 0 1 0. So that means it will take as what 1. Okay, non-zero value. Today 1. Okay, reg y, reg y, and y equal to what? Y equal to, so reg y and y equal to what? Not of a. Okay, logical not of a. So logical not of a means what? Y equal to 0. Y equal to 0. Okay, like that it will take. Okay, we'll see the program related to this logical operation. Okay, dialing divider. Yes. One second. One second. You see here, right? What is there? See here. So here, what I did means here bitwise AND operation. So I think it's visible. So bitwise AND operation. I'm expanding this. Yeah, I'm expanding this. See here. Module bitwise, not bitwise. I need to go for logical, no? Here, logical AND operation. Okay. So logical AND operation. This is logical AND operation. Okay. So module logical AND. Uh, Reg 2 down to 0 ABC. I mean initialize reg 2 down to 0 ABC. Reg XYZ. Initial begin. A equal to what? 5 I took. Okay. A equal to 5 and B equal to 3 tick binary 111 and C equal to tick X. Okay. Tick X. X equal to A logical end of B. Y equal to A logical end of C and z equal to what? B logical end of 0. Okay, I want to display these values. Okay, the dollar display the value of x is percentage b, y is percentage b, z is percentage b, x, y, z end and in module. Okay, so here what is happening, like suppose if I copy this, one second, I copy this, just I'll paste in this. Okay, I'll paste in this. Okay, yeah. So see here what is happening. That means A you took as what? So A you took as, yeah. So here A equal to what? A equal to 5 means this is what? 101. Okay. B equal to what? B equal to 111. Okay. And C equal to tick binary. So you not indicated any size. Okay. So that means C equal to, it will take as the unknown only. Don't get condition. Okay. In logical operator we already seen this is nothing but 1 and this will take as 1 and this is nothing but x. Okay. Now what is my first expression? X equal to A logical and of B. A logical and of B means what? X equal to 1 logical and of 1. So what is the result? X equal to 1 you are getting. Okay, x equal to 1 you are getting. Okay, and next y equal to what? A logical and of C. A logical and of C means what is A? 1 and C means what? And of x. Okay, and of x. So that means unknown values. So unknown values are what? Either 0 or 1. Okay, so that means 1 logical and of 0 means what? 0. One logical AND of 1 means you are getting 1. You are getting two values. Okay. So two values means y equal to what? X you will get. Y equal to x you will get. Okay. So this is first result and this is second result when you want to display. Okay. And third result if you take z equal to what? B logical AND of 0. Okay. So what is B? Here what is B? 1. No? So 1 logical AND of 0. So this is z equal to what? 0. These values you need to get. Okay, x equal to 1, y equal to x, and z equal to 0. Okay, this I will check. Okay, so I'll check in Vivado. Yes, see here. Whatever I'm checking, whatever I'm simulating, that I need to take as top module. Okay, so which one I'm checking? Logical and no. So this I need to consider as top module. Okay, so top module and run simulation, run behavioral simulation. Run simulation and run behavior simulation so that what values I will get we'll see. Okay, yeah, see here. So you are displaying, that means you will get in the TCL console. See here, the value of x is 1, y is x, and z is 0. Okay, you got no? So in the TCL console, you got this value. Okay, this one I can check in EDA playground also. Okay, just close this and copy this program. So I will open this EDA playground. EDA playground. Okay, and next, so you need to register with your email ID. You need to register with your email ID in EDA playground. One second. So I registered, already registered. So I'm logging with ADA, my mail ID. And after that, here, whatever the test bench are there, you need to write here. And whatever the program are there, you need to write here. Okay, I'm copying this. And in the tools, you need to select Aldec Rivera. Okay, you need to select Aldec Rivera and run this program. So here you got the result. The value of x is 1 and the value of y is what? X, that is unknown, and z is 0. Okay. So like this. Okay. Like this we can do. Okay. And next we'll see the logical R. No. Logical R. Okay. Logical R. Okay. And this is logical R. Okay. So logical R means what? So logical R, this program, just same values I took. Just I'm copying here. Okay. Logical R. Okay, logical R means here, that means here A equal to what? A equal to 5, 101. So it will take as 1, and B equal to 111. It will take as 1, and C equal to what? X. Okay, C equal to X means what? It will take as X. Okay, first a logical R of B. Okay, X equal to what? A logical R of B. So one logical R of 1. So this is equal to what? 1 you are getting. Okay, and second one you take. So one logical R of C means what? X. Okay, so that means the condition, that means two values will be there, either 0 or 1. So one logical R of 0 means what? 1 you are getting. One logical or of 1 means what you are getting? 1 only you are getting. So that means here you are getting y equal to what? 1. Okay. X equal to 1. X equal to 1. Y equal to 1. And third case we'll see. Third case, B means what? 1 logical R of 0. So 1 logical R of 0 means what? 1 only. So Z equal to what? 1 you are getting. Z equal to 1 you are getting. Okay. So this I want to see in the Xilinx Vivado. Whatever you are simulating, that you need to make as a top module. Which one I am doing? Logical R, no? So this one, right click, set as top, right click, set as top. Okay. So I made as top module and run behavioral simulation. Run behavioral simulation. Yes, in the TCL console, here you see. The value of x is 1, y is 1, and z is 1. Okay. You got the output, no? X is 1, y is 1, and z is 1. Okay. In the EDA playground also I can check. Okay. This is nothing but a logical R, no? So just copy this and paste in the EDA playground. Okay. So compared to other tools, EDA playground is simple interface. Okay. Second, copy. Just copy this and paste in the EDA playground. Just 1 second. Copy in paste. Okay. Run this code. Yeah, I got a option answer. The value of x is 1, y is 1, and z is 1. Okay, same answer I got. Okay, and next, logical not, no? Logical not. Okay, so if you see the logical not, this one. Okay, so that means logical not means what? Just I'm copying this and here I'm pasting. Just I'm pasting. So here a equal to what? A equal to 101. Okay, it will take as 1. B equal to 111, it will take as 1. And C equal to tick binary x, it will take as x. Okay, so not of a, x equal to what? Not of a. So that means not of 1. So that means x equal to what? 0. Okay, this is my first answer. And b y equal to what? Y equal to not of b. Not of b means what? Not of 1. So this is y equal to what? 0. Y equal to 0. And z equal to what? Not of c. Okay, not of c. So z equal to what is c value? C value is x, no? C value is x means not of x means you are getting x only. Why? Because not of 0 means what? 1 you are getting. Not of 1 means what you are getting? 0 you are getting. Okay. How many possible combination for x? Either 0 or 1, no? These are unknown values. Okay. Don't care conditions. Okay. 0 or 1. You are getting these values only. Okay. What is my answer? X equal to 0 and y equal to 0 and z equal to what? Don't care. Okay. This I will check in Xilinx Vivado. So I am doing for what? Not operation. No? Not operation. No, bitwise not operation. Logical not operation. Okay. Set as stop model. Just a set as stop model and run the simulation. Run the behavioral simulation. Yeah. See here. So in the TCL console. The value of x is 0, y is 0, z is what? X. Okay. Same thing I got, no? So here, value of x is 0, y is 0, and z equal to x. Okay. So this one I can check in the EDA playground also. Just copy this code, and paste in this EDA playground, and select Aldec Rivera. Okay, Aldec Rivera is already selected. Run this code. Value of x is 0, value of y is 0, and z is x. Okay, I got this operation. Okay, so this is about the logical operator. In the logical operator, you have logical and, logical or, and logical not. Okay, next we'll go with the bitwise operators. Okay, what are these bitwise operators? We'll see. Okay, bitwise operators. Okay, bitwise operators. So
Yeah,
bitwise,
hi.
yeah. Any doubt you have?
How, how we are considering A is 1.
What is your doubt? Please ask me.
How can we consider A as a 1?
A as the one means in which way, which one you have doubt?
Everywhere you have taken a as 1, right? 101 is considered as
Yes,
1.
yes. Actually, in the logical operator, if it is a non-zero number, it will take as true condition. That is one. Suppose if it is a equal to all zeros are there means it will take as 0. That is false condition. Okay. Either non-zero value. Non-zero value means what? 0, 0, 1, 2. How many possible combinations? 1, 1, 1. No. So all
Yeah.
these cases it will take as one only true condition.
Oh,
The
okay, fine.
compile understood. Compiler will take that value.
Yeah.
Suppose yeah x. So I told in the initial state. Initial only I told you in the logical operator. What are the
Yeah,
values?
I
Yeah, you
misunderstood
missed
that.
it. Okay. Now you understood, no?
Yeah, sure.
Okay. So next is bitwise operators. Okay. So bitwise operators you have AND operator. Okay. AND operator is only one ampersand. Okay. And next OR operator. OR operator is this is OR operator. And next you have XOR operator. XOR operator is cap. And XNOR. Okay. XNOR is two symbols are there. One is not and bitwise not and cap or cap and not. Okay, and you have negation operator. So negation or we can call as bitwise not. Bitwise not. Okay, so bitwise not this is negation operator. Okay, so that means here it will do bitwise operations. Okay, suppose same example we will take. Suppose if you consider range 1 down to 0 a comma b. Okay, and range 1 down to 0, let us take c. Okay, c. Okay, and so C equal to A bitwise and of B. Okay, so let us take the A value is what, 2 tick binary 1 0, and B equal to 2 tick binary 1 1. Okay, how it will do? So A equal to 1 0 and B equal to 1 1. Okay, it will do bitwise operation like AND gate we are doing, no? So AND gate, so 1 and 0, 0 and 1 is 0, 1 and 1 is what, 1. Okay, so the result C equal to what, 2 tick binary 1 0, 2 tick binary 1 0. Okay, like this is bitwise AND operation. Okay, suppose this is example 1. If you take, this is example 1, and if you take example 2, so example 2, let us take A equal to 2 tick binary 1 0 and B equal to 2 tick binary 0 1. Okay, 0 1, 0 1. Okay, I want to do bitwise AND operation. Okay, A and operation. Okay, this is same only. Okay, 1 0, 0 1 means what it will do, and operation this is 0 and 0. Okay, C you are getting what, C equal to what you are getting 0 0. Okay, 2 tick binary 0 0 you are getting. Okay, uh, third example you take A equal to 2 tick binary 1x, B equal to 2 tick binary 0 1. Okay, and taking range 1 down to 0, range 1 down to 0, y. Okay, y equal to what, A and B, y equal to A and B. Okay, so 1x and 0 1. Okay, this is AND operation. This is AND operation. So AND operation if you take, that means 0 and of 1, what you are getting 0, 1 and of 1, what you are getting 1. Okay, two possible values you are getting, so that means this is unknown. Okay, and next 1 and of 0 means what, 0. Okay, in this case you are getting y equal to what, 0x. You are getting y equal to 0x. Okay, like that you can do it. It will do or operation also. Okay, a or b means what, 1 0 0 1. Okay, bitwise or operation it will do. Okay, so that means this is this is 1 and this is 1. Okay, bitwise or operation. So here this example if you take, do the bitwise or operation 0 1. Okay, bitwise or operation. So 0 R of 1 means what? 1 you are getting. 1 R of 1, you are getting same value. So that means here you will get 1 and here you will get 1. Okay. So that is the difference. Similarly, bitwise X or bitwise X NOR. Okay. All those things will be there. Okay. So same like a logical, gates we already seen. No? So same like that it will do. Okay. We'll see one program related to this. See here, bitwise AND operation. Okay, so same example I took. Okay, same example I took. So here if you see, okay, so if you see the same example, A equal to what? So first I initialized range 2 down to 0, A, B, C. This is 3 bit, and X, Y, Z are also 3 bit, 2 down to 0. Initial begin. You know that if you are writing multiple statements, you need to write between the begin and end. Okay, initial begin and end. Okay, so A equal to what, 1 0 1, and B equal to 1 1 1, and C equal to, C is how many bit length? 3 bit length. Okay. So here I not initialize the C. I initialize what? I not initialize the size. Tick X. Tick X. Okay. So that means this is 3 bit. It will take as what? 3 bits. X X X. Okay. So X equal to what? A and of B. Okay. So 1 0 1 1 1 1. Okay, so that means AND operation if you it will do, so 1 and 1 is 1, this is 0 and this is 1. Okay, so here x equal to 101, x equal to 101. Okay, and next what is y equal to A and C. Okay, 101 x, x, x. Okay. What you will get? 1. This is AND operation. This is AND operation. 1 AND of 0, you are getting 0. 1 AND of 1, this you are getting 1. So this is x only. This is also x. This if you take 0 and of 0, you are getting 0. 0 and of 1, what you are getting? 1. Okay, this is 1. 1 you are getting. Okay, x 1 x. Here you are getting y equal to what? X 1 x. Y equal to x 1 x you will get. Okay, and z equal to what? B.
0 and
0 and of 1, 0, right?
0, right?
Which one?
0 and of 1 is 0.
0. Okay, 0.
There.
0 x 0 x. Okay, x 0 x. Here z equal to what? Z equal to 1 1 1 and operation of 0 0 0. You are getting 0 0 0. Okay, na? So these are the results you will get. We'll see in the Xilinx Vivado. Bitwise and operation. 1 second. Bitwise and operation. Yeah, this one bitwise and operation. Okay, same program. Bitwise and which one I am doing? This one I am doing, no? So right click, set as stop, and run simulation, run behavioral simulation. Yeah, see here, the value of x is 1 second. X is 1. Okay, 1 second. I close this. I'm doing logical bitwise, no? Bitwise and operation. Set as stop, set as stop, set as stop, run simulation, run behavioral simulation, run behavioral simulation. So here, see here. So I got for bitwise and operation, the value of x is what? 101, and y is x0x, and z is 000. Okay, I got this one. And next bitwise r, if you see bitwise r, bitwise r, this one bitwise r. Okay, bitwise r. So right, so where in the simulation I need to take as top module bitwise r, set as top, set as top. Okay, it is made as top, run simulation, run behavioral simulation. So if you run the behavioral simulation, what you are getting? The value of x is 111, the value of y is 1x1, and z is 111. Okay, 1x1 means in the R operation you can analyze. Okay, how you are getting means you can analyze. Okay, so that means 1x. So here, so 111 R operation of what? R operation of B means what? 101. Okay, A is 101. You are getting what? 101, and A and C. So 101 and
That's
XXX.
0 plus 0
Or
or 1 is 1, right?
111. Okay, sorry,
Yeah.
111. 111. And this one, what you will get? So this is 1, and this is 1, and this is also what you are getting? 1. So 1 R of 0, you are getting 1. 1 R of 1, you are getting 1. Okay. 0 R of 0, this is X you are getting. 1x1. Okay. So the 2D is giving same answer. No? Y is 1x1 and Z is 111. Z is 111. Okay. So like that you can analyze. XR operation also you can analyze. Okay, I think you can analyze bitwise XR. Okay, bitwise XR, bitwise XR. Here I wrote. Okay, same values I took and I did a bitwise XR. Okay, you can do with same values. So what output I will get, we will see. Okay, bitwise XR. No, 1 second. Bitwise XR. Right click, set as stop. Run simulation. Run behavioral simulation. Here I got the values. The value of x is 0 1 0, y is x, and z is 1 1 1. I think you can analyze. Okay. Similarly, bitwise XNOR also. Bitwise XNOR means just a complement of XOR you will get. Okay. bitwise x nor, bitwise x nor, set as top, set as top, uh, run simulation, run behavioral simulation. So I got the values x equal to, just complement of XR you will get 101 xxx and z equal to 000. Okay, like that we can see the bitwise operation. Okay, so this is about the bitwise operators. Okay, bitwise operator, bitwise and, bitwise or, bitwise XR, bitwise XNOR. Those are the bitwise operators. Okay. Next we will see the reduction operators. What are these reduction operators? Reduction operators. Okay, reduction operators, like you have bitwise not. Okay, bitwise not is a reduction operator. Suppose if you consider NAND is there. Okay, NAND. Okay, NAND means what? Suppose if you consider x equal to NAND of and a. Okay, and a, let us take a equal to what? 101. Okay, 101. So what it will do? First it will do the AND operation. Okay, first it will do the AND operation. So this AND operation is what? 0. Not of 0 means what? You are getting 1. Okay, only one operand will be there. Okay, so that means here x equal to what? 1 you are getting. 1 you are getting. Okay, and suppose NOR is there. NOR. NOR means how we are doing? NOR means bitwise NOR operation. So x equal to uh, x equal to not of or a. Okay, I'm taking same value a equal to 101. 101 means 1 or 0 or 1. Okay, so this is 1 you are getting. 1 you are getting. Not of 1 means what? You are getting 0. Okay, this is NOR operation. Okay, and XOR operation. XOR operation means x equal to not of cap of a. Okay, this is x x NOR. Okay, bitwise x NOR operation, reduction operator, x NOR operation. First you are taking a equal to what? 101. 1 XOR 0 XOR 1. Okay, so that means even number of ones, so you are getting 0. Not of 0 means what? You are getting 1 equal to 1. This is bitwise operator. Okay, so reduction and reduction or reduction XOR. Okay, and next concatenation operator. So what are concatenation operator? Concatenation operator. Okay, these concatenation operators we are using the shift registers. Okay, concatenation operators. Okay, suppose concatenation is nothing but what? Combining. This is nothing but combining. Okay, this is nothing but combining. Let us take a equal to 101 and b equal to, let us take 011. Okay, combining. So let us take x equal to you are using a flower bracket a comma b. Okay, flower bracket a comma b. So that means it will combine. So what you are getting? So 101 and 011 you will get combined. Okay, this is concatenation. Okay, it's equal to 101 and 01, and you concatenate with 1 bit also. Okay, so that means I can write b equal to x equal to b of 0 comma a. Okay, so this is so if you consider the index, this is 0 1 and 2. Okay, so bit 0 of b I'm concatenating with a. Okay, so that means what is the result? Result you are getting bit 0 of b is 0 and a is what? 101. 101 you are getting. Okay, and we can do the repetition by using concatenation. Repetition by using concatenation. How we are doing repetition? So that means x equal to 2 tick 2 tick and x, 2 tick x. Okay, so that means here it will be repeated by how many times? 2 times. 101 101. Okay, so this is the repetition by using concatenation operation. Okay, concatenation operation. Okay, and next you have shift operations. Okay, shift operations are logical shift. Okay, shift operations are two types. One is logical shift and arithmetic shift. Okay, logical shift and arithmetic shift. So what are these shift operations? Shift operations. You have logical shift, and arithmetic shift. Arithmetic shift. Okay, logical shift and arithmetic shift. So what are these logical shift and arithmetic shift? Suppose like we'll see the logical shift. Let us take y equal to what? Y equal to 0 0 1. Okay, logical shift right by one position. Right by one position. So what happens if we are doing right by one position, it will be shifted. Whatever the vacant position is there, that will be loaded with 0, and this will be shifted. 0 you get, here you will get 0. Okay, you are getting y equal to what? 0. Okay, this is logical shift right. Okay, and similarly logical left shift means what happens? Logical left shift means here y logical left shift 1. Okay, logical left shift means 1 means here my value is 0 0 1. So here this will be left shift. Whatever the vacant position is there loaded with 0, here you are getting 1 and here you are getting 0. Okay, so this is a logical left shift. It will go out. Okay, you are getting y equal to 0 1 0. Okay, and so how many number of times you want to shift, that many number of shifts it will perform. Okay, that is logical shift. And next you have arithmetic shift. What is arithmetic shift? Arithmetic shift, you have left shift. Okay, left shift is like the symbol is like this. Okay, so 3 less than, and right shift. Right shift is 3 greater than, 3 greater than. Okay, so here left shift is same as logical shift only. Suppose if you take y equal to 0 0 1. Okay, if you are doing arithmetic left shift by one position, same as logical shift it will do. So that means it will like vacant position is loaded with 0. Here it will be 1. You are getting, this will be shifted, and this will be shifted 0. Okay, you are getting 0. But right shift, if it is there, right shift, it is mainly used for signed numbers. Suppose if you take value 1 0 1. Okay, so if you are doing right shift, if you are doing right shift, okay, so right shift by one position. Okay, y is right shift by one position. This MSB bit will be hold. Whatever the MSB bit in the signed numbers we already seen, no, MSB decides the given number is positive or negative. MSB is 1 means what? Negative number, and MSB is positive means, MSB is 0 means positive numbers. Okay, so after holding this, again this will shift. This is the difference between the logical shift right and logical arithmetic shift right. Okay, arithmetic shift right. Okay, this is the, there is a special case is there. So special case is suppose if you take a equal to 3 tick binary 0 1 x 0 1 x. Okay, not of a. What is not of a? Not of a. So not of a is a logical not of a is what? This is 0 you are getting. Okay, why? Because 0 1 0 0 1 1. Okay, these are the two possible values. It will take as 1 and it will take as 1. So that means not of 1 means what? You are getting 0 only. Not of 1 means you are getting 0 only. Okay, these are the special cases. Special cases. And if you consider one more case, a equal to some 3 tick binary 0 0 x. Okay, 0 0 x. So if you see 0 0 0, okay, it will take as false condition, and 0 0 1 it will take as true condition. Okay, so that means not of a. Okay, not of a, not of a equal to what? So the compiler will give as what? Unknown condition. Why? Because in this case you are getting 0, in this case you are getting 1. Okay, so like this we can see this one. And next you have relational operators. Okay, relational operators. So what are relational operators? It will check for the condition. Okay, either either it is output have either false condition or true condition. Okay, so false condition, true condition. Okay, false condition is 0, true condition is 1, and unknown is x. Unknown is x. Okay, unknown is x. Suppose you take a equal to 4 and b equal to 3. Okay, so a is greater than b. If this condition is true, that means true condition, it is 1. Okay, output you are getting 1. Okay, true condition. If a is less than b, a is less than b means what is the output? Output you are getting 4 is not less than 3, no? Okay, false condition. And a is greater than or equal to b. A is greater than or equal to b means what? Output is true only. It is greater than, no? You are getting true condition. Okay, and a is less than equal to b. Okay, it is not equal and it is not less than. Output is false condition. You are getting 0. Okay, and let us take this is case 1, and let us take case 2. Suppose a equal to 3 tick binary 0 0 x. Okay, and b equal to 3 tick binary 1 x 0. Okay, so here what are the values for a? Two values you'll get. Why? Because unknown is there, no? 0 0 0 0 0 1. So this is 0 and this is 1. Okay, and b equal to two values you'll get 0 1 second. This is 1, no? This is 1 0 0 1 0 1. Okay, this is 4 and this is 5. Okay, 1 second. Maximum shape reached. Okay, yeah, I'll open the PPT. Yeah, yeah, see here. So that means here, so here a equal to what? A equal to you are getting 0 comma 1 and b equal to 4 comma 5. 4 comma 5. So that means here a greater than b. A greater than b. So what value you are getting? Though a greater than b means what? 0 greater than 4. So the condition is not satisfying. In this case, you will get don't care. Why? Because two values are there. No, two values are there. Okay. So you are in this case you are getting x value. If it is a greater than b, that is x value you are getting. Okay. And next you have logical equality. Logical equality. Logical equality is this is the symbol for logical equality. Okay, logical not equality. This is logical not equality. Okay, and next you have equality operators. Case equality. Case equality. So case equality, if you consider, three equality symbols are there, and here not of two equal symbols are there. Okay, this is case equality. Okay, so logical equality, if any one of the bit is x in the input, any one of the input bit is x, you are getting output is what? X. Output is x. Okay, so we'll see with one example. Suppose a equal to 3 tick binary xx1, b equal to 3 tick binary 0 1 1. Okay, so A not equal to B. If A not equal to B, so that means here 1x is there, 2x is there. So any one of the input is unknown, you are getting output equal to what? X only. Okay, output equal to X only. But with respect to case equality, it will compare with the don't care only. Okay, it will compare with the don't care. Suppose if you take A equal to 3 tick binary 101 and B equal to 3 tick binary x01. Okay, x01. So A not a case equality of B if you take. So here what it will do? So 101 x01. Okay. So that means if you consider these both are not equal, no? You are getting output equal to what? It will compare with, so this is equal, but the one is not equal to don't care. You are getting output equal to what? Condition is satisfying. You are getting output equal to 1. Okay. So this is about equality operator. And next you have conditional operator. So what is conditional operator? So conditional operator. So conditional operator is you have this is nothing but ternary operator. Ternary operator. Ternary operator. So ternary operator means what? You have three operands. Okay, you have binary operator, unary operator, binary operator, and ternary operator. Okay, so unary operator means you have only one operand. Binary operator means two operands, and ternary operator means three operands. Okay, so what is the syntax for this conditional operator? Syntax is condition, condition, expression, expression. Okay, if condition is true, okay, if condition is satisfied, true expression, else false expression, else false expression. Okay, so like this, suppose we'll take one example. Suppose if you take one example, yeah. So I'm taking range 3 down to 0, a b c y z. Okay, a equal to 40 binary 1010, and b equal to what? 40 binary 40 binary 0010, and c equal to 40 binary 1110. Okay, y equal to what? C. Y equal to c, then a. Okay, otherwise b. Okay, what is the meaning of this? That means if y equal to c, then y is assigned to what? A. A means what? 1010. Okay. If y is not equal to c, then y is assigned to 0010. Okay. This ternary operator we can use in the mux also. Okay. Suppose if you consider mux, okay, you have selection line 2 cross 1 mux. Okay, ternary operator you can use. Okay, so this is let us take a b. Okay, y. Okay, so I can use with one, so I'm using assign y equal to what? Y equal to like y equal to s. Okay, which is connected b, otherwise a. Okay, so what is the meaning in this? That means if s equal to 0, y is connected to what? So b, y is connected to b. Or if s equal to 1, here s equal to 1, y is connected to b. If s equal to 0, y is connected to. Okay, so like this. Okay, these are the operators. Okay, like this you have like some more like addition operator. Okay, so arithmetic operators also you have. So what are those arithmetic operators? You have arithmetic operators, arithmetic arithmetic operators. Okay, arithmetic operators are addition operator. Okay, so this is addition operator. Okay, and next subtraction operator, and next division operator, Okay, this is nothing but division means what? You are getting coefficient. Okay, and next modulus operator. So modulus operator means you are getting remainder. Okay, so like this. Okay, so that means in conclusion, so how many operators you have? So first we discussed about the logical operator. Okay, logical operator, you have what operators? logical. So in the logical operators, first you have logical operator. So in the logical operator, you have logical and, okay, and next logical or, and logical not, okay, logical not, okay, and next you have bitwise operators, okay, bitwise and, bitwise or, and bitwise XOR, and bitwise XNOR, and bitwise not, okay, and next you have reduction operators. In the reduction operators you have NAND operator, okay, NAND, reduction NAND, and reduction NOR operator we already seen, okay, and next concatenation operator. Concatenation operator means combining, okay, flower bracket, and repetition by concatenation. Repetition by concatenation. What is the repetition by concatenation? N of x, okay, and next we already seen shift operators. Okay, shift operators, you have two types: logical shift, and arithmetic shift, okay. Logical shift are again right and left, okay. Logical right shift, logical left shift, okay. Arithmetic again right shift, and arithmetic left shift, okay. And next you have okay. Relational operators, you have greater than, less than, greater than or equal to, less than or equal to, okay. And next equality operators. What are the equality operators? Logical equality. So logical equality is this is equality and not equality. Case equality means this is case equality, okay. Case not equality, okay, that we see the difference, okay. And conditional, ternary operator, okay. Conditional operator, or we can call as what, ternary operator, okay. So syntax also we already seen, that means a expression the expression is true expression, false expression, okay. And arithmetic operator, okay. Arithmetic operators, you have addition operator, subtraction operator, okay, and next division operator and modulus operator, okay. These all are the operators present in the Verilog, okay.